So hello everyone, especially to our instructor, Mr. Anthony Gamali. Good day, sir. By the way, I am Ladrachula Miguel from B Scream 2, Section A. So, by the way, um, today I will discuss to you the topic that I choose, the chapter 2, the photographic rays, its natures and characteristics in a book of forensic photography. So, before start, so what is photographic rays? Photographic rays is a reflected light rays from the object exposed the film to produce an image. So in investigator, in law enforcement, there is some definition about the photographic rays. Photographic rays is essential tool for the law enforcement investigator. As a tool, it enables him to record the visible and in many cases, the invisible evidence in crime. So that is the definition of photographic rays. So let's go to the topic, the light. Light is a characteristic of photographic rays. Light is one of the number of known form of radiant electromagnetic energy which travels in wave motion. So there are other theories that explains the behavior of light. Example is the one the quantum theory. But before we go to the quantum theory, let's see what is the wave motion. This is the example of wave motion. So wave motion or the wave theory, this is the form of energy that travels at a speed of about 186,000 miles per second in air. But they are differ in a wavelength and frequency. So wavelength. So as you can see, this is the wavelength, the wave of the wave motion. So wavelength. So what is wavelength? Wavelength is the distance from the crest to the wave to the next succeeding crest, while frequency is the number of waves passing in the given push point of in a second. So so let's go to the topic of the quantum theory. Quantum theory is a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. So I have some examples of quantum theory. So this is the example of quantum theory. But this is not actually the explanation of the light. So the true explanation of light is what we call the wave theory. So as we see the example I have given late the day. So this is the wavelength. The definition of wavelength. Wavelength is the distance from the crest to the wave to the next succeeding crest, while frequency is the number of waves passing a given point in 1 second. Wavelength is measured by the Armstrong unit in terms of millimicrons or nanometer, which is equivalent to 1/1,000,000 of millimeter. So this is the example of the wavelength. So this is the wave motion, while this at the corner of the wave is the wavelength. So this is the distance between the wavelength and the wave motion. So the frequency here is in the middle. So there are some different energies in an electromagnetic spectrum. The number one is the cosmic rays. So this is the example of cosmic rays in the electromagnetic spectrum. Cosmic rays is a highly energetic atomic nucleus or other particle traveling through speed at a speed approaching that of light. So this is the cosmic rays. As you can see that it is very light and bright. So another example is gamma rays. So this is the example of gamma rays. Gamma rays is a penetrating form of electromagnetic radiation arising from the radioactive decay of atomic nuclear. So this is the example of gamma rays. Next is the next different energies is the X-ray. So this is the example of X-ray. So the definition of X-rays is an electromagnetic wave of high energy and very short wavelength which is able to pass through many materials opaque to the light. So this is the example of X-ray. Next. Another example of another different energies in the magnetic spectrum is the ultraviolet rays. What is ultraviolet rays? Ultraviolet rays, it has a shorter wavelength than visible light. You cannot be able to in our human eye, so you cannot see it in our human eye. For example, is the heat of the sun. So like the heat of the sun or to our skin. So this is the example of ultraviolet rays. Another different energies in this electromagnetic spectrum is infrared rays. Infrared rays rather. Infrared rays is the electromagnetic radiation which wavelengths longer than those of visible light. So I have the example of infrared rays. So as you can see, it is like the X-rays, but it has color. The difference of the two is the infrared rays is have different colors if you see in the picture. So another different energies in electromagnetic spectrum is Hertzian waves. So what is Hertzian waves? Hertzian wave is an electromagnetic wave produced by the oscillation of electricity. So I have there for example of Hertzian waves. So it is like in the hospital when we are going to go to the hospital. You can see it in the hospital room. So I have there a definition of light. So light rays with a wavelength of 400 to 700 is referred to as a visible light because it is only within this wavelengths that the human eye is capable of perceiving. Those with shorter or longer wavelength are commonly referred as invisible radiations. So invisible radiations now is heat of the sun. So that was we call the invisible radiations. Light energy has several effects on an object. It is either reflected, absorbed, or transmitted. So the light energy has three objects: the reflected, absorbed, and transmitted. So I have there the examples. These are the properties of light. So as you can see, the reflection. For example, the reflection is in the mirror. So if you put the mirror in the light of the sun, it can reflect. It can reflect. So the next properties of light is the absorption. Next is the transmission. Okay. So the verifying combination of these reflectance and observance are what gives us wide of variety of colors, which are able to perceive at times. Other lights are neither reflected or absorbed, but it is transmitted through objects. So if the light of the sun will with reflectance to the absorbance of wide variety of colors, it can gives a variety of colors like rainbows. So before we go to the two types of luminescence, so I have the definition of lights in the Webster dictionary. So in the Webster dictionary is the light is defined as a radiant electromagnetic energy that can seen by the naked eye. So light is when you can see at the naked eye. The scientific definition of light is the aspect of radiant energy of which human observer is aware through the visual sensations which arise from the stimulation of the retina of the eye. So light rays which a wavelength of 400, so light narasya. So light energy has several effects on an object. So there are some several effects of light energy. It is either reflected, absorbed, or transmitted or converted. So the verifying combination is reflectance and absorbance are the what we give as the wide variety of colors. So this is it. The wide variety of colors if the heat of the sun will reflect to an object. So this is the rainbow. It can be rainbow. So the final effect of radiant may be have non-object. The final effect, a radiant energy may have an object is to be converted to another wavelength. So this conversion rather is known as luminescence. So we can call it luminescence if the heat of the sun were converted into the wavelength. So we can call it as luminescent. So there are two types of luminescent, the fluorescence and the phosphorescence. So this is the type of luminescence. Fluorescence. Fluorescence is the ability of an object to convert one wavelength to another as long as the active energy source is irradiating the object. So the number two types of luminescence is the phosphorescence. So phosphorescence is the object not only converts the wavelength while being irradiated but continues to reflect the new wavelengths for a period time after the energy source is removed. So let's go to the next topic, the white light. So white light. White light is, so before we read that is, I have definition here in white light. White light is apparently a colorless light. For example, an ordinary daylight. It contains all the wavelengths of the visible spectrum at equal intensity. So this is the example of the white light. So when all the wavelengths between 400 to 700 nanometers are presented in the eye nearly equal quantity, we get this sensation of perception of colorless or white light. If a narrow beam of white light is allowed to pass through a prism, so this is what we call the prism. So this is the white light. So if the white light reflect to the prism, it can make a rainbow color. So if a narrow beam of white light is allowed to pass through a prism, so this is the prism. It will bend the light of shorter wavelength. So it will bend the light. So it's what we call the rainbow. Shorter wavelength more than those with longer wavelengths, thus spreading them out into the visible spectrum. So So if the white light will pass through the prism, it will make a rainbow color. So next. So next is the additive color mixture. So what is additive color mixture? Additive color mixture is a mixing and creating a new color by a process that adds one set of wavelengths to another set of wavelengths. So, muna siya. So, I have there an example of additive color mixture. So, as we can see, this is the red, the blue, and the green. These are the three primary colors. If we mix them up, it will it will it will um it will make another color like for this. If we if we if if we mix the red and the blue, it will come up the pink color. While if we mix the blue and the green, it will come up a sky blue color. If the red and the green also will come up a yellow. And if we mix them three colors, the three primary colors rather, if we mix them up, it will make a white color. So this is the example of additive color mixture or the three primary colors. So let's go to the subtractive color mixture. So what, by the way, what is subtractive color mixture? Subtractive color mixture involves the absorption and selective transmission or reflection of light. So absorption and selective transmission or reflection of the light. So I have there an examples of subtractive color mixture. So there we go. So the subtractive color mix. So the additive color mixture is that the blue, green, and red. So in the subtractive color mixture, so if we mix the pink, yellow, and the sky blue, it will come up a red, blue, and green. And if we mix the three colors, the pink, yellow, and sky blue, it will come up a black color. So this is the subtractive color mixture. So the range of colors, which can be produced by subtractive mixture. So this is produced by the subtractive color mixture. Of through days is quite large and makes it possible the modern process of color photography which depend on subtractive principle. So that is all the subtractive color mixture. So let's go to the next topic. Is the production of colors. So production of colors, I have there a 5 production colors. Number 1 is the absorption. So what is absorption? Absorption is the color of most ordinary objects are due to the fact that they do not absorb the same amount of light and each wavelength. So from the word absorb, the light of the sun will absorb through the object. So for example is the soil. So the soil. I have there an example of absorption. So this is the example of absorption. Number 2 production of colors is the scattering. So what is scattering? Scattering is the color of the blue sky is due to the scattering of light by the atmosphere. So I have there an example of scattering. So there. So as we can see there, this is the light. So if the light of the sun will reflect on an object, it will scatter. For example, the leaves of plants or flowers. Then the next types of production of colors is the interference. So what is interference? Interference is a color can also be produced by interference of light waves in thin film like in soft bubbles or film of soil floating water. So I have there an example of interference. So, interference. This is the example of interference. So as we can see, the light reflected from the top surface. So this, for example, this is the sun. So this is the top surface of the sun. As we can see, the light reflected from the top surface of such a film undergoes a reversal or phase, but the light reflected from the bottom surface that must undergo the type of change. So this is the light of sun. So this is the interference. So this is the interference. For example of this is the um, heat of the sun. Heat of the sun. If it will reflect to the for example is the in the like in the sa Bisaya ato. So this is the example of interference. This phenomenon is also responsible for the color pattern known as the Newton's ring. So this is the Newton's ring. As you can see, this it is like a ring, which sometimes cause trouble in color printing work. So the heat of the sun, if will reflect on another object, it will change the color of the object. So next is the so this is another production of colors, the fluorescence. So what is fluorescence? Fluorescence, this happens when the molecules of the fluorescence materials absorb energy at one wavelength and radiate it another wavelength. So this is the example of the fluorescent. It's like we use to our especially at home. The next production of colors is the dispersion. Dispersion. So what is dispersion? Dispersion is a color may arise from differences in the refractive or bending power of a transparent medium of light of a different wavelength. So I have there an example of dispersion. So this is the bending power of transparent medium. So this is an example of the dispersion in the SD card. If we put the SD card in the heat of the sun, it will come up in different types of color. It is like a rainbow. So this is the bending power of transparent. So this is the example of dispersion. The next topic is the attributes of color. So what is the attributes of color? So, as my opinion about the true attributes of color, this color has its own appearance based on the three key attributes. There are three key attributes of the attributes of color: the hue, chroma, and value. So, it is very important to use all three these attributes to accurately identify the colors and distinguish it from others. So in the book definition about the attributes of color is each color has its own appearance. So each color has its own appearance based on three key attributes: the hue, comma, and value. It's important to use three of these attributes to accurately identify the color and distinguish it from others. So I have there an example of attributes of color. So, according to the modern scientific definition of color, it is not legitimate to ascribe color to an object but only to the light reflected from it. So, thus any color perception has three characteristics. So any one of which can be varied independently or that other two. These are the hue, saturation, and the brightness. So that's all the attributes of color. So next topic is is the bending of light. So bending of light. So I have there and so before we start bending of light, I have the definition of bending of light. So bending of light as it passes from one medium to another, and it is called as refraction. So as we called as refraction. So like I don't ini I didn't get an example of refraction, but I have there three types of bending of light. So the number one is reflection. So what is reflection? Reflection is the deflection or bouncing back of light when it hits the surface. So I have there an example of reflection. So this as you can see, this is the sun. So bouncing back of the light. So it will so this is the reflection. So for example, is the mirror. Okay, the mirror. So the next bending of light is the refraction. So refraction. The bending of light will passes from one medium to another. So I have there an example of refraction. So as we can see, this is the pencil. If we put the pencil inside the glass of water, this is the example of refraction. Next is diffraction. Diffraction, the bending of light, like when it hits a sharp edge of an opaque object. So this is example of refraction. So this is the white light. So this is the refraction. If the white light will pass through the diffraction, it will come up different colors. So the next is kinds of object and how they behave to light. So I have there and kinds of object as they behave to the light. So the number one example of kinds of object is the transparent object. So transparent object, for example of transparent object is like glass of water, like for example is the glass. So allows sufficient visible light to pass through dim that the object on the other side may be clearly seen. So may be clearly seen. So this I have there an example is the glass of water. So it was we call the transparent object. The number two is the translucent object. So for example of translucent object is the colored glass. Okay, colored glass. So allows light to pass. However, diffuse it sufficiently that objects on the other side may not be clearly distinguished. So, for example of the translucent object is the translucent object. This is the cup of bottle, plastic bottle that have color. If the heat of the sun will reflect to the translucent object, it will come up to what object of the color. So, for example, is the color of the cup is blue. So, if we going to hit it from the sun, it will come up the color. So, it will light or sample or bright. Next is the opaque object. So opaque object. So greatly diffuse the light, the recognition the object on the other side. Excuse me. It is very different if not visible. So I have there an example of opaque object. For example, is the opaque is the apple. So we are going to hit the apple. So there is no light will come up. For example, another example is that is the roof. So roof we are going to use today the roof in our home. So that is the kinds of object of and how they behave to light. So the next topic is the source of light. So we are going to see the source of light. So the number one source of light is the natural light source. So natural light source. So what is natural light source? So natural light source, those coming from a nature like the sun, moon, stars, or other heavenly bodies, lightning, fire, or etc. So with sunlight, these are actually several sources. Primary those coming directly from the sun. Secondarily, those being reflected by clouds or sky. So I have there a kinds of shadow casted by an object in an open space. So these are the parts of the natural light source. So another an example of the kinds of shadow casted by an object in an open space is the bright sunlight. So what is bright sunlight? Bright sunlight is a lighting condition where objects in an open space cast a deep and uniform distinct of shadow. So I have there an example is the light of the sun. So light of the sun, if the light of the sun, for example, today, like heat of this a good day, or example a good morning. Next kinds of shadow is the hazy sunlight. So hazy sunlight, what is hazy sunlight? Hazy sunlight is an object in an open space cast a transparent shadow. So transparent shadow, so as we can see the transparent shadow is like cloudy day. So I have there an example. Transparent shadow is like a noon or an afternoon day. So this is the example of hazy sunlight. So next kinds of shadow is the dull sunlight. Dull sunlight. So what is dull sunlight? Dull sunlight is an object in an open space cast no shadows. So there is no shadow in this sunlight. So I have there an example. So this is it. The example of the dull sunlight. There is no shadow. As you can see, there is no shadow. So next topic will be the number two. There are two types of dull sunlight. The cloudy bright, and the cloudy dull. So what is cloudy bright? Cloudy bright is an object in open space, cast no shadows, but objects at far distance are clearly visible. I have there an example of cloudy bright. So in Bisaya is, as we can see, is hayag. So kibali kanang buntag sayo or cloudy day. So the types of dull sunlight as another is the cloudy dull. So the cloudy dull, objects in open space cast no shadows, and visible of distance object are already limited. So I have there an example of cloudy dull. So as you can see, in Bisaya it was what we called dagum. So dagum in Bisaya. So it will also. So these are the example. There's are the two types of dull sunlight. So let's move to the number two source of light, the artificial light source. So what is artificial light source? So artificial light source is a light source of this category are man-made and is divided into the continuous radiation and the short duration. So this artificial light source is is a man-made object. For example, I have there an example. Um, so I have there are two types of so so let's go to the other artificial light source. So the example of artificial light source is like a man-made. For example, is the lamp, the torch, fire. So those are the example of artificial light source. So artificial light source have two types: the continuous radiation. So what is continuous radiation? Continuous radiation are those that can give illumination continuously. The common light source of this kind are the fluorescent lamp, incandescent lamps, carbon arc lamp, photoflood lamps, gas lamp, and etc. So those for example those lamps fluorescents are belong to the continuous radiation of the types of artificial light source. So I have there an example of continuous radiation. A lamp. So as you can see, this is a fluorescent rather. So let's go to the types of artificial light source. The short duration, or as we call, is a flash unit. So what is a flash unit? A flash unit gives a brief of light produced by a burning metallic wire or an electrical discharge through a gas filled with tube. So this is a another man-made object. So I have there an example. So this is the example of a short duration flash drive. It will easily get like in Bisaya is lubat. Kaya malubat. So this electronic flash, so this the electronic flash. So this is electronic flash. So the electronic flash offers a great light output in a compact, lightweight, and economical form. It does not have the effect of heat and glare during setup, setup. That are common continuous light source because it is battery powered. So this is battery powered. This flash unit is battery powered. While this continuous radiation is like a switch. We can use switch from this continuous radiation. So let's go. Let's go to the next topic. The forensic light source. So what is forensic light source? What is forensic light source? Forensic light source is created using a lamp containing filters for ultraviolet, visible, and infrared light. So I have there a forensic light source. Number one is the ultraviolet lamp. So this is the ultraviolet lamp. So what is ultraviolet lamp? Ultraviolet lamp is used in a forensic work, come in variety of shape, size, and power. Some units are portable, battery operated, and are easily carried and can meet the rugged and rigorous demand for field work. So that is the meaning of ultraviolet lamp. The next forensic light source is the laser. So what is laser? So laser is the light application simulated emission of radiation. So laser stimulation of these items provide a way for a criminalist to finally see locate, and visually record evidence that they know that they had been missing. So the criminal investigation will use the laser to find and record evidence that they have missing. The next source, the next forensic light source is the alternative light source, or as we call it, ALS. Alternative light source is it was developed in mid 1980s as far as far as far for more inexpensive alternative to forensic lasers. The ALS use a variety of band pass filters to provide a high-intensity beam of non-coherent light. These multiple band pass filters allows the operator to match the laser frequency available at crime scene. So the next is the forensic light source. So what is, as we call this, the FLS. So what is the forensic light source? Forensic light source is a term being applied 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 to a wide variety of relative inexpensive light source which use filtered white light. A band of pass filters allows a fairly narrow band of light to pass through. The object is then radiated with what is normally about 400 to 500 nanometer light of source. So those are the forensic light source. So thank you and God bless. By the way, I'm Ladrachulo Miguel from B Screen 2 student in section A. So thank you and God bless.